Hey students, this is lesson 4.7. We're going to learn how to identify and extend patterns and sequences and to represent arithmetic sequences using function notation. Go ahead and do this review here and I'll check back with you. All right, so we want to describe the pattern in each sequence. What are the next two terms of each sequence? So you might notice in this first one that the sequence starts with 4 and then each subsequent number is 2 more than the last. So if we continue that pattern, we would get 12 and then 14. And the next one, it's a multiplication pattern. It starts with 1 and each subsequent number is 3 times the previous number. So 27 times 3 is 81, times 3 is 243. And I'll write down how I describe those. All right, go ahead and try that. Check back with your answers. All right, in arithmetic sequences, the difference between the consecutive terms is constant. The difference is called the common difference. So to be called an arithmetic sequence, you need a common difference between the numbers. So if you look at these two, if you look at the difference between the numbers, so the difference between these numbers, 7 and 11, so 11 minus 7, and then 16 minus 11, this is how we're going to find a common difference, 22 minus 16, and we get 4, 5, and 6. So those aren't the same numbers, so there is no common difference. So we're going to say this is not arithmetic. And the second one, if we subtract 9 minus 3 is 6. 15 minus 9 is 6, 21 minus 15 is 6. There is a common difference. This is arithmetic. And the common difference is 6. All right, try that. All right, a rule for arithmetic sequence. Pay close attention here because I'm going to change that. For the Minnesota State standards, we don't use this rule for arithmetic sequence. We use the 0th term. So a sub 0 here. Let me just rewrite this. A sub n is equal to a sub a of 0 plus nd, and a of 0 is the 0th term, so the term before the first term, and n is the term number in the sequence, and d is the common difference. So I'm just going to skip this one. I won't even bother with that. And we'll get right down to writing a rule using that. Okay. Justine's grandfather puts 100 in a savings account for her on her first birthday. He puts 125, 150, 175 on her next 3 birthdays. So let's just write out the sequence: 100, 125, 150, 175. And that continues. And this is her first birthday, second birthday, third birthday, fourth birthday. The arithmetic sequence rule is this: a sub n is equal to the a of 0, which means when the input is 0, what is the output, plus n times d, where n is the term number and d is the common difference. Well, D is equal to 25 because it's going up by 25. A of 0, the zeroth term, would be 1 back here. Since we know the common difference is 25, we'll just subtract that to get that. 75, and now we have everything we need to write the rule. Equals 75 plus 25 times n. And you might recognize this as a linear type equation. And we want to know how much she'll have on her 15th birthday. So we're going to do 75 plus 25. Did I get that right? Oh, 12th birthday, sorry about that. Not her 15th, but her 12th. And 25 times 12, and that's 75 plus 300, so $375 on her 12th birthday. Pretty generous grandfather. All right, you try that. And right here, you should be doing just n, not n minus 1. Notice here that it actually makes sense to say the 0th term and not the first term in this situation, because if you wrote 0 times, you would pay 100. All right, that's it for this lesson. Go ahead and do the lesson check, and I'll talk to you about this next time we meet in class.